Hello friends, in this video our topic is a data structure which is a very important data structure which is called Q, and Q is a linear data structure just as we have discussed in our other previous videos about another linear structure called stack, and this Q is a linear data structure which maintains the discipline called FIFO. In the acronym it is called FIFO, and FIFO means first in, first out. And that is the discipline of the elements being added and deleted will be done in the order of first in, first out. That is, the elements, when it is to be added to a queue, the element which is first added to the queue will be deleted at the beginning of the deletion process, and the last element added to the queue will be deleted at the last. Just like as in the case of the real world example, when we stand in a queue in any sort of ticket counter or in the bus stop or in any other situation in which we find ourselves standing in a queue, then the discipline which we follow, that is the FIFO discipline which we follow over there, is being is just similar to what we will just discuss about the discipline of the queue. So Q is an important linear data structure which can be implemented as an array as well as a linked list. So first our discussion will be on the Q as an array. So in the Q as an array, there the structure declaration, which I will just show you in a bit, will contain an array containing a finite number of spaces or elements. The array can contain the finite number of elements, and along with there will be two important parameters. Just as in the case of stack, we have taken a top integer variable. In this case, we have to maintain two integer variables, that is, one is rear and another is front. Why rear and front? Because the elements will be deleted from the queue from the front position. That is, one element which is at the beginning of the queue will be deleted first according to the FIFO discipline, and elements which are to be added to the queue will always follow the FIFO discipline in the way that they will be added at the end of the queue, at the rear end of the queue. So we need two important parameters in order to describe, or in order to handle with the primitive operations dealt with the queue by taking those two important parameters, and those are front and rear. So there are other aspects of the queue. So let's first write some important points to be noted about the queue. That is, when the queue is empty, when the queue is non-empty, what should be taken as the front and the rear, and what is the length of the queue, etc. So just I will write a few points on the board and explain it one by one to you friends. So a queue can be understood like this. We are implementing obviously the queue as an array. So suppose this is an array. It contains a finite number of elements. Starting position is 0, 1, 2, 3, 4, 5, etc. Now we can have some elements stored over here in the data structure Q. That is, the array is implemented as Q over here. So in this case, suppose the first element occupying the queue is in this 0th position, then this position, then this position. Suppose there are three elements. Suppose there are three elements in this queue, and in this queue, front, when the queue is non-empty, suppose let me write the point first. Number one is, if the queue is non-empty, then front always to be taken as one less than the index of the beginning of the Q. So it is a very important point to be noted about Q. That is, if the Q is non-empty, as in this case, we are seeing that the Q is holding 3 elements. In this case, the Q, since the Q is non-empty, we will take the front to be 1 less than the index of the beginning of the Q, so as to handle the operation of deletion of the Q. So just we'll study the addition and deletion operations later on, and then you will get to understand fully why I am doing this sort of things. This is quite similar to the concept of the top being initialized to -1 when the stack was empty. So in this case, if the Q is non-empty, you always take the front to be 1 less than the index of the beginning of the Q, which will help us in the primitive operations to be performed on the Q. So the front can be thought of as a value containing -1 in this case, because the index of the beginning of the Q is 0, then 1 less than the index of the beginning of the Q is obviously -1. So front will be taken as -1 and rear will be taken as this position. So rear is 2 in this case. Suppose in this case I delete the first element from the Q. So in the course of the deletion, the first element from this side will be deleted, and in that case the front will always be 1 less than the index of the beginning of the Q. So now the index of the beginning of the Q is not 0 but 1. Then the front will be changed to a value of 0. So this front will always be pointing to this 0th index. So front will be updated to 0. Another element, if it is deleted, then the front will be incremented by unity, and in this way we always see that if the Q is non-empty, then front always is to be taken as 1 less than the index of the beginning of the Q. This is the first point to be noted. Second point is that the empty condition of the Q. What is the empty condition of the Q? As we have seen in the stack, the empty condition of stack was top is equal to -1. But in the case of the Q, the empty condition is nothing but the empty condition of Q is front equals rear. That is, if we write like this, if front equals rear, we can print the Q is empty. So this denotes that the Q is empty. To be the empty Q, the condition front equals rear always holds. So this is a very important point to be noted, friends, that the Q, if it is to be empty, always has this condition to be true, and that's why I have written an example code snippet like this: if front equals rear, then printf the Q is empty, like this. And number 3 point which is to be noted about Q is that what is the length of the Q? Suppose, see this, in this case front is now how much? Front is now 0. Front is 0 and rear is unchanged, that is rear is 2. Now see, if we write this formula, length of the Q is rear minus front. See this, please tally it with the situation over here. Rear is here 2, front is 0. So 2 minus 0, that is rear is 2, front is 0, rear minus front is 2 minus 0 is equal to 2. So see this, the length of the Q, there are 2 elements. So the length of the Q is definitely 2. So this formula gives an answer which is quite exactly what is being seen in this pictorial representation. So these are the few important points to be started with in the overview part of the Q description. So if you have any doubts or queries relating to this portion which I have discussed in this video, you can well post your doubts and queries in the comment section below so that I can address them. Thanks for watching this video.